So, today we continue to learn about calculus, and we will learn two things today. First, differentiating the negative and fractional powers. We already learned that derivative of x in the power of n equals what?
nx to n minus 1.
nx n minus 1. But that works for any n. That works for any n. If it's positive, or it's negative, or it's fraction. For example, what will be derivative of x in negative 2?
Negative 2x times
Negative 2x in negative 3. Same thing. You take power coming outside and power and drops by 1. If it will be, let's say, x in the power 3/4.
Negative. What is x negative what? Part of
3/4, x in the power 3/4 minus 1, negative 1/4. Same rule. It doesn't matter whatever n is. So as an example, let's find derivative of the next function. Let's say we have f of x equal 3x in the power 3 on 2 minus 5x in negative 4 plus 1. So derivative will be equal the constant factor going out of the derivative as we learned, so will be 3, stay there, times power comes out, times 3 on 2, x in the power 3 on 2 minus 1, 1/2. Now, minus 5, but we will have minus 4 coming out. Negative times negative, positive. So we'll have plus 20, x in negative 5. And what will be derivative of 1? 0. So just simplifying this, so 9 on 2, x in the power 1/2 plus 20, x in negative 5. Everyone fine with that?
Yeah.
Pretty simple, straightforward. But our main focus is today on the graphs of the derivative function. Graphs of the derivative functions. And first, let's see how derivative is related to increasing or decreasing of the function. Let's consider a very simple example. Let's consider function y of f of x equal x squared, which is very basic. F of x equal x squared, and you all know this graph very well, just a basic parabola, yx, and let's find derivative. F dash of x equal what?
2x.
2x. Now, when x is greater than 0, derivative will be positive or negative?
Positive.
Positive. And what function does when x positive? Is it increasing or decreasing? Increasing. So, this is the condition for function to increase. If derivative is positive, that means function is increasing. For x less than 0, this will be negative. F dash of x will be less than 0. Will be less than 0. So what function doing here?
Decreasing.
It's decreasing. So that will be derivative less than 0 is a condition for function to decrease. Now, what happens at x equals 0? What derivative of 0 equals? And that is minimum, which is stationary point. We will focus later on more on the stationary points, or type of stationary point, how we identify what type of stationary point. Now, if if I will sketch the graph of some like random function, and we have those will be x1, x2, or let's say a, b, and c instead of x1, x2. This is a1, this is a, this point is b, and this point is c. Where on which intervals function is increasing? Where derivative will be
between negative infinity and a.
From negative infinity to
B
a.
and C.
Is a included?
No.
No. Because derivative will be at a will not be positive. It will be 0. Now next interval where function is increasing, b to c, again not including them. So function increasing on the interval from b to c. And so makes sense if you just look on the graph, you can identify where derivative positive, where derivative negative. Now, if we sketch a tangent line, let's say at this point. We sketch a tangent line at the point, let's say, x equals d. The angle that this tangent line makes with the x positive direction x-axis will be theta. What will be the relationship between this angle and derivative at the point D? Any ideas? What will be the relationship between the value of the derivative at the point D and angle that the tangent?
Wouldn't it just be the graph of the derivative? Wouldn't it be the graph of the derivative?
Yes. Yes. We will have that the gradient derivative will be equal gradient of the tangent line. Because that we learned before. That the gradient of the tangent line at the point gives the value of the derivative at that point. It's an instantaneous rate of change, which is derivative. And that is tan of the angle theta. And that is the angle, this is a tangent of angle theta, because gradient of the straight line equal tangent that of the angle that that line makes with the positive direction of x-axis. Does it make sense? Okay, which part doesn't make sense? I keep it to re-explain. Don't, I'm telling you, don't be scared to ask.
Yeah. Asking like, why does the gradient equal tan theta?
Why the gradient of the line?
No, how did that link to the derivative?
What is derivative?
I don't know. It's,
Is that
when it's like
instantaneous rate of change?
It is a gradient of the tangent line that is instantaneous rate of change. How do you find? We find an average rate of change between 2 points.
I know what instantaneous the word.
We draw the second line connecting these 2 points and find the gradient.
Different.
If we will be
What's the
making
gradient?
Yeah, but it's like the
going
gradient is.
closer, and then we will get the tangent line.
Okay.
And the gradient of the tangent line
Same as gradient
I
of the
don't-
point.
the
is
Oh.
We have the same word
is
as
the instantaneous rate of change. It tells us how fast function changing at that particular point.
Yes. Yeah, that makes
And
sense.
from linear relation, you should know when we have a line, straight line, the gradient of that line equal tangent of the angle the line makes with the positive direction of x-axis. Now,
Yes, that makes sense. Thank you.
let's do a couple examples. Let's do a couple examples. If we have I will sketch few functions and we will be finding what will be the graph of the derivative function.
Okay.
What will be the graph of the derivative function? So this first is with this point being 3. This point will be 3. This is quadratics. What is the derivative of the quadratics? What function will be derivative of the quadratic function? Linear function. Because derivative of x
Is
squared
one
is
less
2x.
power.
So the will be graph of the derivative will be straight line.
Oh.
Now, what function doing up to x equals 3?
It's
It
decreasing.
decreasing. What we know about the sign of the derivative and function decreasing?
It's less than 0.
It's negative, yes, less than 0. When function from this point onwards increasing, derivative positive. And here derivative equals 0.
Yeah.
Yes.
So that we can say that will be graph of the derivative. It is negative up to x equals 3. At x equals 3 it's 0 and then it's positive. To make it like exactly, we need to know the equation of this parabola. We cannot say what will be exactly the gradient, but we can definitely say, we need more information to make exact equation of this line. But we can definitely say that that will be straight line, because derivative of the quadratic is linear function.
Of course.
At x equals 3, it has to be 0. For x less than 3, it has to be negative. When x greater than 3, it has to be positive. Does it make sense how we constructed or sketched the graph
So
of
just
the
with one point you can
all
find
one by one, yes.
just with one point you can find the graph of the derivative.
We cannot find it exactly because I don't know. Will it be y equal 3x minus 2 or something like that? I need to know more about that function to find it. But general behavior, we can find that it will be straight line. It has to be below x-axis to the left of the 3, above x-axis to the right of the 3,
At 3.
and at 3 it has to be x-intercept.
Okay, yeah.
Yes.
Why does it have to be below the x-axis or left?
Because it's
Because
negative.
what function doing here?
Decreasing.
What is the sign of the derivative and function? It's negative.
Left. Okay. Got it.
Now,
Decreasing when it's less than.
next function.
X is
Yeah.
negative. I mean y is negative.
Maybe. Do you think if I order salad and I didn't like that, I can pick it up now?
You are recorded.
It's fine. I'm not embarrassed about picking up a salad.
Leo, you're so geeked.
Next function. That is cubic function. With those points will be, let's say, -1 and 2. What will be the derivative of the cubic?
Quadratic.
Quadratic.
And it's going
Because power going 1 down. Now,
Oh, and it's going to the
Oh,
here what should be derivative equal at x equals minus 1? What derivative should be? 0. What derivative should be equal at x equals 2? 0. Now, here, function to the left of x equals negative 1. What function does? Increasing or decreasing?
Increasing.
Increasing. That means derivative is positive.
Linear graph is a
Between minus 1 and 2, between negative 1 and 2, function decreasing, so derivative has to be negative.
Wait, but on the left side, the black line is increasing and the red line is decreasing.
It doesn't matter increasing, decreasing in this case.
Oh, because it's
We're
just
looking at
negative.
the derivative positive or negative. When function is increasing up to
can be
this
more-
point,
ah.
it has to be positive. Here it has to become 0.
Yeah.
How it can be?
Get it, Miles.
How it should behave? Going down.
Yeah.
Now, yes, question?
Episode. Very long one.
No. Now, next is a challenging question. This derivative you will learn actually next year, but we already can guess it.
Oh no. Oh no. So is that a sign? Oh,
Yes, it's sine graph.
God.
It is a sine graph.
That's evil.
It is a sine graph, so this is 1, obviously.
What?
This is a sine graph. Let's build derivative, just look at, let's construct derivative of the sine, just looking on this graph. So, what should be derivative when we have this, if this point is pi on 2, pi on 2, this is pi, and so on. What derivative should be equal at x equals pi on 2? 0.
What?
Now,
Because like this, the gradient.
again, it has to be 0 at negative pi on 2. And what function, what sign doing between minus pi on 2 to pi on 2?
Increasing.
Increasing. So derivative has to be
Positive.
positive. Now, then function start decreasing up to here. No, it's decreasing,
Also, it's like a
and
cosine.
then it becomes 0 here, and start increasing, become positive. What graph we obtain? Cos graph. So derivative, it just looking on the graph, we worked out that the derivative of sine x equal cos x. Equal cos x. This is not part of unit 1, 2, it's part of 3, 4.
Sorry, it's not about whether the derivative is increasing or decreasing. It's about
It's whether it's positive or negative.
So what's positive or negative? Y equals 0.
Or could you say that it's also just like a sine graph shifted by pi on 2?
Sorry?
Could you say that it's also just a sine graph shifted by pi on 2? Is that what it is?
Cos is, to get cos from the sine, we need to translate it pi on 2 to the left, get sine from the cos, we translate it. That's why we had that sine
So when
pi on 2 minus theta was equal cos theta. And vice versa.
Oh, that's right.
Yes.
Is that why? He did tell us that.
Okay, that's all what I wanted to explain today. Like, subscribe and donate to help fight terrorist countries and organizations, Hamas, Iran, Russia, etc. Support Ukraine and Israel.